going on, guys? In this video we are going to see how to find unknown voltages using nodal analysis method. Now in order to do nodal analysis method, first thing we have to do is we have to connect this bottom to the ground. In that way this is going to be 0 voltage, and for other nodes we are going to set, like we are going to give V1, V2, V3, something like that, right? So here if you notice we have 3 nodes. Other than the bottom part, we have 3 nodes right here. We have 1 node right here. So node is basically when we have more than one branch connected, right? So here we have 1 node and 2 node and 3 node. So for these 3 nodes we are going to name it as V1, V2, V3. Now then we have to apply Kirchhoff's current law, and you know that Kirchhoff's current law is basically whatever the current that enters must equal to the current that exit, and also addition of currents in node should be equal to 0. So we can state that same current law in two different way, right? So first one is where current enters must exit, and addition of all the currents in one node should be equal to 0. Now let's see which one we can apply for the first one. So here we have 3 milliampere is entering, so we put 3 milliampere, 3 milliampere, and whenever we don't have current provided, current and direction provided, we always assume that is exiting. So here these two other things are going to be, we assume those two exiting, right? So this is going to be exiting, mean this bottom is 0. So for V1 it's going to be, for this part this is going to be V1 minus 0 over 500, right? So V1 minus 0 over 500, so we can directly write V1 over 500, and plus we have current also going through. Let's put something like the I1, I2 to make this one clear. So now we have I1, we put it as V1 over 500, I2 we can put it as starting from V1 going to V2, so this is going to be V1 minus V2, and the resistance in between that, right? So that's 500. So we are representing this current because if you remember, V is equal to IR and I is equal to V over R. V is voltage drop or voltage rise over the resistance. So that's why we like this is basically current we are putting right here in terms of voltage, and this is for the first node, right? And this is our first equation. Now we can go ahead and simplify this one, because milliampere is basically 3 times 10 to the power minus 3 ampere. So what we can do is we can multiply both sides by 1000. If you multiply this one by 1000, that's going to be just 3 ampere, right? So we can write 3 is equal to, and if you multiply other side by 1000, that's going to be 2v1 plus 2v1 minus 2v2, and if we combine them, that's going to be equal to 4v1 minus 2v2, right? So this is our first equation. Now let's look at the second node. So second node, again, now we have to forget about the first part. Now again we have to look at from this node and assume when we don't have the current, we assume it's always leaving. So this one is leaving, this one is leaving, this one is leaving. So the better equation would be when we add all these three, that should be equal to 0. So let's start with this one. So this is going to be V2 minus V1. The second equation is going to be V2 minus V1 divided by 500 plus, then this way we have a current leaving, so V2 minus V3 over 500 plus, and also this way we have a current leaving, that is V2 over 1 kilohertz, it's 1000, I mean kilo ohm is 1000 ohm, so we can put V2 minus 0, bottom is 0, right? So V2 minus 0 over 1000, and that's equal to 0. Now to simplify this one, we can multiply this one by 1000, and if you multiply this equation by 1000, this is going to be 2v2 minus 2v1 plus 2v2 minus 2v3 plus v2 is going to be equal to 0. Now if we combine all of them together, this is going to be 4v2 5v2, so we have totally 5v2 right here, minus 2v1. So let's put v1 in front, 2v minus 2v1, this is plus, and we don't have any v3, so this is equal to 0. So this is our second equation. Okay, here we have v3 also, so this is minus 2v3 equal to 0. So this is our second equation. Now let's go ahead and create our third node equation. So for third node, again we should get rid of the previous direction we assumed and look at the next one. Now we have 4 milliampere entering, the direction is provided, so we can put it right here. 4 milliampere is equal to, and other two are not provided, so we assume both of them are exiting, right? So let's take this one. This is going to be V3 minus 0 because it's going to the ground, so V3 minus 0 over 500 plus, and this one is going toward V2, so this is going to be V3 minus V2 over, this is second and this is our third, V2 minus V3, actually V3 minus V2 over 500, and again milliampere is 10 to the power minus 3, so if we multiply this equation by 1000, this is going to be 4 is equal to 2v3 plus 2v3 minus 2v2. So finally we are going to have 4 is equal to 4v3 minus 2v2, and that's going to be our third equation. Now we can create our matrix. So if we create a matrix, we put v1 in the first column, v2 in the second column, v3 in the third column. Now let's look at the first equation. First equation we have 4v1, so we put 4 right here, and we have minus 2v2 minus 2 right here, and we don't have any v3, so we put 0 for that one. And the second equation we have minus 2v1, so minus 2 here, and we have 5v2, so we put 5 right here, and we have minus 2v3, so we put minus 2. And in the third equation we have 4v3 and we don't have any v1, so this is going to be just 0 v1 and minus 2 v2, and we have 4 v3. So this is our matrix, and then that is that v1 v2 v3, that's what we are trying to find. And other side of the equation we are going to have this number after the equation sign. So first one we had 3, and in the second one we had 0, so second one is 0, and third one we had 4, so this is 4, and we have to do the Cramer's rule. And when you do the Cramer's rule and find the final answer, you will end up with this one. v1 is going to be equal to 4 over 3, and v2 are going to be equal to 7 over 6, and v3 is going to be equal to 19 over 12. And that's how we do this kind of problems. I hope you guys find this video helpful. See you next time.